So class, that concludes my lecture on protein folding. Are there any questions? How do you feel about the topic?
I still don't understand what proteins are and why they fold the way they do. Could you go over it one more time?
Sure, but first, do any of you think that you can explain it to him?
I can. Remember those amino acids that are so essential to life? Proteins are long chains of amino acids that fold onto itself to form the most stable conformation.
But how do proteins know what is the most stable configuration? Can't they fold in an infinite number of ways?
Wait, does it have something to do with Leventhal's paradox? The paradox states that there's no way proteins can fold in infinite ways, but tends to follow specific pathways instead.
Exactly.
Hold on, that really doesn't explain things. Professor, can you start over from the beginning?
Yes, of course I can, but I want you all to pitch in and help your classmates out. It'll help you retain the information a lot better. Let's start with consistent themes of protein folding. So what's the first step that happens?
The first step of protein folding involves secondary structures via hydrogen bonding. Imagine Christmas lights. It's just like a polypeptide chain with the lights as the R group. Now let's say you store the Christmas lights. The first thing you would do is fold the Christmas lights into segments, like how the polypeptide chain folds into alpha helices and beta sheets.
Yeah, that's correct. The secondary structures form first. But so what happens next?
The next step is hydrophobic collapse. The nonpolar residues will be forced into the interior of the folding protein, as this is thermodynamically favorable because of the increase of entropy of water. Imagine you are at a party that is off the his day. However, there are a few shy people standing in your way of dancing with those really hot chicks or guys, and it is super annoying. So in order to move freely around the party, you push all those shy people into one corner so you can dance with those hot chicks or guys.
Wow, that's a really great analogy. So as you can start to perceive, the folding isn't as random as you might think. As a protein folds, hydrophobic residues minimize interactions with water by congregating together. Hydrophilic residues will maximize polar interactions by orienting positive chemical groups close to negative ones or by being in a position close to water molecules. Although the resulting folded structure is more ordered and gained entropy, the process of folding is thermodynamically favorable due to the formation of hydrogen bonds and the decrease in total energy. This means that folding will happen spontaneously without the need for the input of outside energy. The decrease of energy as the protein folds is visualized through the free energy funnel. An unfolded protein exists in a multitude of conformations. As these different conformations begin to fold, they both decrease in energy and the number of variations of structure. The result is a single conformation with the lowest amount of energy possible that was obtained through more than a single pathway. So now can anyone tell me the next step of protein folding?
After the hydrophobic collapse, you would expect to see long-range interactions like disulfide bonds and ionic interactions between R groups, between intra and or interdomains. Imagine again you're at a party and you're hanging out with your group of friends, but you see another person you're totally attracted to. So you go interact with him even though that person is in a totally different group than you.
Awesome, I think you guys really paid attention to this lecture. You all should do fabulously on the next midterm. Can someone please tell me about the chaperones and their role in protein folding?
Aren't chaperones proteins that help with protein folding? They help prevent certain interactions from happening and help reverse incorrect folding that takes place. So in a way, they are like chaperones at a school dance that make sure no funny business happens and stops inappropriate dance moves.
Yeah, that's correct. You guys are really smart and also creative with these analogies. Okay, can someone please tell me about how protein folding leads to protein flexibility and its role in enzymes?
Wait, I think I know this one. When the protein folds, there are some pockets of empty space within the protein. Like for example, take the Christmas lights. When you put them in a box to store, there are pockets of empty space that allows the Christmas lights the ability to move around slightly. This flexibility helps the enzyme motion during ligand binding and enzyme catalysis and regulation.
Okay, I think all of you guys got it. The key to remember is that protein folding isn't random and that a polypeptide chain folds in thermodynamically favorable ways. Mostly folding happens by hydrogen bonding with neighboring residues to form secondary structures, and having nonpolar residues conjugate into the core. Along with some further long-range interactions, that's the main way that proteins fold to get their 3D conformations that's necessary for their function.